Hello friends, in front of us there is a question of vector in which three vectors have been given and this relationship have been given, that is u cross a equal to b cross c, in which ABC is known and u and a are perpendicular to each other. So if we take a magnitude both sides, since u and a are perpendicular, so it will be only magnitude of u in magnitude of a, sin 90 is 1, and this can be written as b square c square minus b dot c whole square. Magnitude of u, magnitude of a is root 40 and b square is 11, c square you can see is 9 minus b dot c you can see as 5, which is 25 if you do the square. Hence magnitude of u equal to 74 by 14 over root, that means 37 by 7 square root. Hence 25 times magnitude of u whole square is 37 into 25 divided by 7. So you will get this option B. Now in front of us there is a next question. We need to find range of this. So that's a regular question of finding range. So just you can do the cross multiplication and x square coefficient will be y minus 1 and 2x coefficient will be 4y minus 1 and constant term would be y minus 1 equal to 0. So discriminant greater than 0. This will give us 4 into 4y minus 1 whole square minus 4 times y minus 1 into y minus 1 again, which is greater than 0. So 4 you can cancel. So we are left with 4y minus 1 whole square into y minus 1 whole square, which we can factorize like a plus b and a minus b, that is 5y minus 2, and if you take the difference you will get the 3y only is greater than 0. So if you do the sign scheme, roots are 0 and 2 by 5, so plus minus plus, so this as well as this, because we want the positive. So y lies between 2 by 5 to infinity and minus infinity to 0, and straight away we have this option B. Now we have again a problem on vector in which ABC magnitude have been given and this relationship have been given. So you need to notice that a and a are same. So we can write this relation as a cross 2b. If you bring that side, that minus sign will be consumed, so you can write as plus 3c, because minus a cross c you can write, equal to null vector. That means 2b plus 3c vector is parallel to a, parallel or anti-parallel. Just take the magnitude to find the value of lambda, that is 4b square. Note that b magnitude is half, so b square is 1 by 4, 9c square, that is 4, plus 12 b dot c, b magnitude is half, c magnitude is 2, into minus half, because angle between b and c is 120, equal to lambda square, a square magnitude is 31. So 36 minus 6 is 30 plus 1 31, so 31 will be cancelled from both sides, so that is lambda is plus minus 1. Hence we have two choices, whether 2b plus 3c vector is plus minus a. Now they have given, we need to find a cross c magnitude divided by a dot b. So if A cross C have been given as A cross B, basically this is the problem of finding A cross C. Magnitude is nothing but 2/3 of A cross B magnitude divided by A dot B, because A cross C can be written in terms of A cross C can be written in terms of A cross B. So basically angle between AB is required. So if we take dot product with B, because B dot C we know, so take dot product with B, it's better. So 2b square is 1/4 plus 3b dot C. So B is half, C is 2, and the angle between them is -half, equal to plus minus A dot B. So magnitude of A is √31 and magnitude of B is half A dot B, and cos theta we don't know, or let's say we find A dot B only. So plus minus A dot B. So here 2 gets cancelled, so and half, so half minus 3/2, that is -1. So A dot B value is plus -1. So A cross B magnitude you can find as magnitude of A whole square, that is 31, into magnitude of B square, that is 1/4, and minus A dot B whole square, that is 1. So 31 minus 4, 27. So 27/4 is square root. So they want the ratio of this value. So what is this value? We have found that is 2/3. A cross B magnitude is 3√3 divided by 2, and A dot B is plus minus 1. So from here 2 gets cancelled, 3 gets cancelled, so our answer is plus minus √3. Only minus √3 is available, plus √3 is not available, so we'll take this option B. Moving on to the next problem, which is a PNC problem. They are saying 7-digit odd number you need to find using only these 7 digits. Odd. Note that if you take if you find the odd number of odd numbers, so at the last place either you will put 1, 3 or 5, but there is a problem with 3. 3 comes twice, so you need to make a two cases. Or if you want to avoid case, then go by the complement way. So total number of numbers just you find without any restrictions. So total number of numbers, that is 7 places are there, just you need to arrange in factorial 7 ways, but 2 comes 3 times and 3 comes 2 times. So factorial 7 divided by factorial 3, factorial 2, so that goes to 7, 6, 5, 4/2. So that is equal to 35 and into 35 into 2, 70, 70 into 6 is 420. So 420 such numbers. Total number of such even numbers. So subtract this one. Total number of even numbers equal to, that is easy to find because in these 7 places 1, 2, 3, 4, 5, 6, 7, this is fixed that at the last place you need to must put 2. So 1, 2 is fixed, and rest you need to arrange because there is only one even digit, that is 2. So rest is 6 digits. So you need to arrange 6 digits, factorial 6. Out of these, double 2 comes and double 3 comes. So 6 120 into 6 divided by 4. So this is 30, 180. So our answer is 420 minus 180. Number of such total number minus number of even numbers. So you'll get the number of odd numbers. So you'll get the 40, 240. So answer is C. Next question is y equal to, note that x square minus x plus 1 is always positive because d is negative. D is 1 minus 4 minus 3. So minus 3, d is negative, so hence it is always positive. So no need of putting the modulus sign. So y equal to mod a plus greatest integer a have been given. So we'll write a plus greatest integer of a. A is that x square minus x. What is a? A is just x square minus x plus 1. So what is the minimum value of a that you can have? Minimum value is minus d by 4a, that is 3 by 4. So a plus greatest a, we need to find minimum value. Note that both minimum can attain at the same point when x is half. When x is half, both a and greatest a is minimum, because a is greater than equal to 3 by 4. So greatest of a, note that greatest of a will always be greater than equal to 0. So minima achieved at the same time. So y minimum equal to a minimum. A minimum is 3 by 4 and greatest of a minimum is 0, and that is achieved at x equal to half. Both is minimum at the same time. So y minimum is 3 by 4, which is option A. Next is the ellipse question. Foci is given at minus 4 comma plus minus 4 comma 0, which means a is 4. And since eccentricity is root 3, so you will get the a value as 4 by root 3. Hence you will get the b value, that is b square equal to a square, that is 16 by 3 into 1, sorry, e, it is hyperbola, it is e square minus 1, so 3 minus 1. So b square is equal to 3 minus 1 to 32 by 3. And we know length of LR is 2b square by a. So 32 by 3 is b square and value of a is 4 by root 3. So root 3 by 4. Now we have a question on a relationship written in alpha, beta, gamma. But actually we do not like in this format. So we'll take transpose both sides. So that the written is, if we take transpose both sides, so this will come this way and this will go that way. So it will be 5, 6, minus 1 this way, 6, 3, 3 and 8, 8, 0. And alpha, beta, gamma will become vertical column vector, and this 0, 0, 0 also becomes a column vector. So now we recognize this is nothing but the system of 3 equations and homogeneous equation. So obviously 2 types of solutions are there, either trivial solution or only trivial solution, or non-trivial solution, which means infinite solutions. So just alpha, beta, gamma you multiply here. So what you will get? The first relation is 5 alpha plus 6 beta minus gamma is 0. Then 6 alpha, beta, gamma, you can cancel 3. So you will write a little bit more easy equation, that is 2 alpha plus beta plus gamma is 0. And again in the third equation you can remove 8 and you can write alpha plus beta equal to 0. So this gives that beta equal to minus alpha. That will put it here. Second one, so what you are getting? Beta equal to minus alpha. So 2 alpha minus alpha, alpha plus gamma is 0. So gamma is minus alpha. So gamma is also minus alpha. Putting in the third one, so minus alpha and minus alpha. So you'll get the minus 6 alpha plus alpha. So minus 5 alpha, that is already satisfied. So it has an infinite solution because this is dependent on these two. Only 2 equation is sufficient. This is trivial one. Hence it has the infinite solution, and alpha, beta, gamma is nothing but some alpha, if you take k, beta will be minus k and gamma is also minus k. K minus k minus k is the solution of this system, infinite solution. But k value you can find because this lies on this one. So you put it over there. So what we will get? 2k minus 5k minus 3k equal to 5. So minus 6k. So k equal to minus 5 by 6. Hence that point alpha beta gamma that you found. So alpha beta gamma is nothing but that is k minus k. So later on we'll put the value of k, leave as it is. What they are asking, 6 alpha, that is 6k minus 5k minus 9k. So this is equal to minus 8k. K value is minus 5 by 6. So 40 by 6, that is 20 by 3, which is option B, straightforward. Now this is a problem of binomial theorem. They are asking the coefficient of x to the power minus 6, but we don't know in which term we'll get the x to the power minus 6. So why don't we write the general term, that is tr plus 1 equal to 9cr and 4x by 5 to the power 9 minus r and minus 5 by 2x square to the power r equal to 9cr 4 by 5 to the power 9 minus r minus 5 by 2 to the power r. So total x to the power is 9 minus r and here 2r, so 9 minus 3r. So 9 minus 3r should be equal to minus 6. That means r must be equal to 9 plus 6, 15 by 3, so r must be 5. If r is 5, so basically in the sixth term you will get the x to the power minus 6. So coefficient you will get as 9c, r is 5, so 9c 5 and 4 by 5 and 9 minus 5, that is 4, and minus 5 by 2 to the power 5. So answer is going to be negative and x to the power minus 6. So this value we need to calculate because they are asking coefficient. So 9, 8, 7, 6 divided by 24. 9c4 I have calculated, and into 4 to the power 4 by 5 to the power 4, 5 to the power 5 divided by 2 to the power 5, and with minus sign. So many things will be cancelled. So 1 5 here, and this is 2 to the power 8, this is 2 to the power 5, so 2 cube is there, 2 cube in numerator, and that will cancel 24. So 3 is there, and that 3 will cancel 6, so 2. So finally we have minus 72 into 70. So that is equal to 5040 with minus sign. So that is our final answer. Now in front of us there is a next question on sequence series, but it's a very calculative one. So that's why I have written all the calculation already. So question is the alternate plus minus sign is there. So what we do, we separate all the terms with the plus sign like this, and we have separated all the terms with the minus sign like this. Now first term you can see 1, 3, 5, 15. So it's basically all odd numbers, that is 2r minus 1. Whereas 1, 5, 9, 29, this sequence is in actually AP with common difference 4, and general term is 4r minus 3 whole square. And there are 8 terms over here because there are total 15 terms in the original sequence. So we have separated the plus terms. So there are 8, and with minus terms there are 7 such terms. And its general term you can see 2, 4, 6, 14. So there is 2r terms, and 3 7 dot dot. This is again in AP with common difference 4, and its general term is 4r minus 1 whole square. So just we multiply this polynomial, which is cubic polynomial, and we also multiply this cubic polynomial. What we found that r equal to 1 to 8, this cubic polynomial product is this, and this cubic polynomial expression is this. Notice that 32 r cube here and 32 r cube here also. So r equal to exactly 8, it will be 32 into 8 cube. This, but for r equal to 1 to 7 and r equal to 1 to 7, 32 r cube and 32 r cube will be cancelled. So only for r equal to 8 will remain. Then similarly for r equal to 8, we have written its value minus 64 into 8 square. For remaining r equal to 1 to 7, r equal to 1 to 7, we can subtract corresponding r square terms. So 64 and this is 16, so minus 48 will come, because minus 64 and plus 18. Similarly for r terms, again for r equal to 8 we have written separately, and for r equal to 1 to 7 we'll club this one and this one together, and at last minus 9 into 8, this constant term. So 32 and this, when we club these two, so 8 to the power 4 is common, so 3 into 8 to the power 4 minus 48 sigma r square we know, n into n plus 1 into 2n plus 1 by 6, 42 into 8 plus 40 into sigma r, that is n into n plus 1 by 2, this one, n into n plus 1, that will become 1120, and minus 72 is there. When you calculate all these, you will get 6952. It's little bit calculative one. Moving on to the next problem. They are saying sum of the elements in A is prime lying between 2 to 30. So there is little bit ambiguity over here whether these two are exclusive or inclusive. But if you take the inclusive, then there will be more cases. So I don't think paper setter intention has to include 2 and 13. So I will take the prime in excluding this 2 and 13. So this A plus B plus C plus D will be either 3, 5, 7 or 11. So we need to go by the case wise. Case 1. A plus B plus C plus D equal to 3. So we need to find the number of integral solution of this, where ABCD is 0 to 4. To find the number of integral solution, so we'll go for no number can exceed actually 3, so there is no problem. So number of integral solution is 3 plus 3, 6. So 6C3. So 3 plus 4 minus 1, that is 6. So 6C3 we have taken. 6C3 is 20. Case 2. Now we need to go for A plus B plus C plus D equal to 5. So number of integral solution of this equation. But there is a problem. If you directly find the number of integral solution, D can be 5 also. However, D cannot be 4. D cannot be 5. So you need to go by the generating function, which means you need to find the coefficient of x to the power 5 in the expansion of A can be x to the power 0, can be x to the power 1, can be x square, can be x cube, plus can be x to the power 4, which means value of A can be 0, 1, 2, 3, 4, only this one. Same goes with the B, same goes with C, so that's why to the power 4. So basically this is nothing but the 1 minus x to the power 5 to the power 4 and 1 minus x to the power minus 4. So we need to find x to the power 5 coefficient. So when we expand this one, the first term, so basically we need to find the x to the power 5 coefficient, that is from 1 minus x to the power minus 4 and minus 4c1 into x to the power 5 into 1 minus x to the power minus 4. The rest term is not required. X to the power 5 higher power that is not required. So from here we will collect the x to the power 5 coefficient. So 5 plus 4, 9, 9 minus 1 is 8. So 8c5 minus 4c1 is 4, and x to the power 5, so you need to calculate x to the power 0 from here, that is 1 into 1. So 8 into 7 into 6 divided by 6 minus 4. So 56 minus 4, 52. Now case 3. Now we need to find x to the power 5 coefficient. Again in the not x to the power 5, sorry, when a plus b plus c plus d is 7. So a plus b plus c plus d equal to 7. So now we need to find coefficient of x to the power 7 in the expansion of, in the same way the a can be 0 to 4 only. So we need to calculate 1 minus x to the power 5 to the power 4 into 1 minus x to the power minus 4. So from here we need to calculate x to the power 7 coefficient. So x to the power 7 coefficient will be so x to the power 7, and again if you expand, so 1 minus x to the power minus 4 minus 4c1 into x to the power 5 x to the power 5 into 1 minus x to the power minus 4, and the higher power is not required. So basically answer will be, from here you see, just we shift little bit so that our work is a little bit easy. So here coefficient of x to the power 7 you will get as 7 plus 4, 11, 11 minus 1, 10c7 minus 4 times, so x to the power 7, so here x square you require, so 4 plus 2, 6 minus 1, that is 5, because x square we require, so x square, so 6 minus 1, 5, 5c2, so total it will be 10, 9, 8 by 6 minus 40. So that is 12. 120 minus 40, that is 80. So in this case we get 80. So here we get 20, here we get 52, here we get 80. One more case is left when their sum is 11. So case 4. So when a plus b plus c plus d equal to 11. Now again we need to find, however 11 is very rare case without doing by the generating function. You can also see ABCD can be only 0 to 0, 1, 2, 3, 4. That's it. So if all of them are 4, 4, 4, then it will be 16. So some are 4, some are 3, but still there will be cases. So let's go by the generating function only, which means we'll go by the x to the power 11 coefficient in the expansion of 1 minus, same as 1 minus x to the power 5 to the power 4 into 1 minus x to the power minus 4. So here, which means x to the power 11 coefficient will be from 1 minus x to the power minus 4 minus 4c1 into x to the power 5, then 4c2 into x to the power 10. Other high terms is not required. Sorry, I mean to also write with x to the power 5, 1 minus x to the power minus 4 plus 4c2 x to the power 10 into 1 minus x to the power minus 4. So x to the power 4 coefficient from the first, x to the power 11 coefficient from the first is 11 plus 4 is 15 minus 1, 14c11 minus 4c1, and to x to the power 6 we require from here, so 6 plus 4, 10, 10 minus 1 is 9, 9c6 plus 4c2 into x to the power 10 is there, so we require x coefficient from here, that is plus 4. So 14c11 is 14c3, so 14 into 13 into 12 divided by 6 minus 4 into 9c3, that is 987 divided by 6, and that is 24. So this is equal to so we can cancel 72 by 6, that is 12. So we are getting as 14 into 26 minus 12 into 28 plus 24. So 14 into 26 as it is. 24 you can take common, so 1 minus 14, so you'll get the 40 into 26 minus 24 into 13. So from here we can get I think 4 common. So here 7 into 13, so 91 minus 78, and that is 8 minus 7, that is 1. Sorry, it's a 13 into 4, so that is 52. So all answer will add here. So 52 here also and 52 here also, that makes it 104, and this is 100, so total 204. So if all cases if you add, you will get the 204 as our answer. Moving on to the next problem. Just it's based on the expansion of this term, NPR term, that is factorial n divided by their difference. Difference is n plus 2 factorial, n plus 2 factorial, and again here the difference is n plus 1 factorial in the numerator, and denominator is 2n plus 1 factorial. This is equal to 11 by 21. So from here this term gets cancelled, and denominator is 1 by n plus 2, that's it, 11 by 21. So n plus 2, sorry, here it is n minus factorial 2n plus 1, and difference is n plus 2, that's okay, factorial 2n plus 1, and difference is n plus 1. So this gets cancelled, so we are getting n plus 2, 1 by n plus 2. It does not matches with the value of n. I think value of n should be integer, because it is written in that format, NPR, where n must be integer, but we are getting so I think it is a 2n minus 1, so there is a mistake. So I think this is 2n minus 1. So if it is a 2n minus 1, so we'll redo it. So factorial 2n plus 1 divided by factorial n minus 1, sorry, difference is n plus 2, n plus 2, and factorial difference is n minus 1 divided by factorial 2n minus 1 equal to 11 by 21 have been given. So if you cancel these two, so you'll get the 2n plus 1 and 2n, and when you cancel these two, so you'll get the n plus 2, n plus 1, and n. So nn also gets cancelled. So finally what we are getting, that is 2 times 2n plus 1 divided by n plus 1 into n plus 2, which is equal to 11 by 21. So 11, so this 2 if you multiply in the denominator, you will get the 2n plus 1, n plus 1 into n plus 2 equal to 11, and this becomes 42. 42 is basically 6 into 7. So if you take from here n as 5, you can see it's 6, n as 5, so it is 7, and n is 5, so 11, so it matches. So here we are getting n equal to 5 as our answer. So there is a mistake in the problem. There should be 2n minus 1. Moving on to the last problem that we have. So just we rationalize the denominator. So what we are getting? X into x plus alpha square root plus root x divided by alpha will also be there, dx 0 to alpha. So 1 by alpha taken outside, and this into this if you multiply and then you integrate. So here we will apply the by parts. X as a second function, which is this is a first function. So x is a second function, or you take this as a better to take x as a first function, and x plus alpha square root is a second function, plus 1 by alpha will remain over there, x to the power 3 by 2, x to the power 3 by 2 is x to the power 5 by 2, and 0 to alpha if you integrate, so it is directly alpha to the power 5 by 2. That's it. So 1 by alpha, and here if you go by the by parts, so x into x plus alpha to the power 3 by 2 and 2 by 3, 0 to alpha, minus x differentiation 1, so x plus alpha to the power 3 by 2 dx into 2 by 3, again integration, plus 2 by 5, 2 by 5 alpha to the power 5 by 2 will remain as it is. So 1 by alpha times, when you put alpha you'll get the alpha, and into 2 alpha to the power 3 by 2 into 2 by 3 is also there, and when you put 0 it becomes 0, so 2 by 3 again, minus, now it is 2 by 3, and when you integrate, so x plus alpha to the power 5 by 2, so it becomes 2 by 5, so x plus alpha to the power 5 by 2, when you put alpha, so 2 alpha to the power 5 by 2, and when you put 0 you will get the minus 0 to the power 5 by 2, 0 plus alpha to the power 5 by 2, plus still we have 2 by 5 alpha to the power 5 by 2. So this is equal to 1 by alpha. So alpha you can divide in by sending inside, so you'll get the 2 by 3 and 2 alpha to the power 3 by 2, minus, and this is 4 by 15, and 1 by alpha if you divide, so alpha to the power 3 by 2 you will have, alpha to the power 3 by 2 and 2 to the power 5 by 2 minus 1, and this will become 2 by 5 alpha to the power 3 by 2. So everywhere we are getting alpha to the power 3 by 2, that we can take common. So from here alpha to the power 3 by 2 will take common, rest thing is 2 by 3 into 2 to the power 3 by 2, and minus 4 by 15 into 2 to the power 5 by 2 minus 1, and plus 2 by 5, and we need to simplify it more, because finally it is 6 plus 20 root 2 by 15 right side. So alpha to the power 3 by 2, but 16 plus 20 root 2 equal to 15. 16 plus, so this is equal to 16 plus 20 root 2 by 15, it is given. Note that just we guess if alpha must be 2, because square root 2 is there and everywhere 2 is also there with the square root. So if alpha is 3, 5 and any other prime, that won't make any sense. because then cubic root of square root of 3 will also come in the picture from the right side, that is not there, which means alpha must be 2, that we are guessing. So just take the alpha as 2 and try. If alpha is 2, so 2 to the power 3 by 2 you will get, that you will multiply with this one. So what you will get, if alpha you take as 2, so 2 by 3 into 2 to the power 3 by 2, so it becomes 2 cube actually, minus 4 by 15 into this is 2 to the power 4 actually, 4 by 15 into 2 to the power 4 minus plus 4 by 15 again, and 2 to the power 3 by 2 and plus 2 by 5 times 2 to the power 3 by 2. So 8 into 2, 16 by 3. This is 16 into 4, 64 by 15, and plus this is 2 to the power 3 by 2, you can take common, and 15 is the LCM. So 6 plus 4, 10 by 15. So 10 by 15 into 2 into root 2, that you can write. And here again it is 80 minus 64, that is 16 itself. So 16 by 15 plus 10 by 15, sorry 20 by 15 now, 20 by 15 root 2. So that matches, you see 16 plus 20 root 2 by 15. So our guess was correct. Hence alpha is 2. That is our answer.